Hello, grade 12s, how are you? Once again, Mr. Newlove is here. We are still trying to sort out things to assist us on our final exams. Somebody gave me this question, and I think I need to share. Okay, this is one of the questions in your trial exams. It says calculate the maximum value of s if s is equals to 6 over x squared plus 2. You know, anytime a denominator is becoming small, the number becomes big. Let's prove it from here. For instance, I have this expression. If I substitute 5 for x, this value becomes 0.2. Alright, you can press it on your calculator to check. If I reduce the value for x, it means the denominator is reducing. Are you getting it? So if I reduce the value for x, you know this 2 is constant. So it is this variable that we can change. So if I reduce the value for x, now what will happen? I'm going to have 0.3. You see that the value of that expression has increased from 0.2 to 0.3 when I decrease the denominator. Are we together? Now let me reduce the denominator again. Now I'm reducing the x value to be 3 from 4 to 3. You see that the whole expression increases from 0.3 to 0.5. So let me do the next one. If I reduce it to 2, it becomes 1. If I reduce it to 1, it becomes 2. So it means if I tend to reduce it to 0, if I reduce x to 0, the whole expression becomes 3. And we want the maximum value. So if x approaches 0, this expression, that's the denominator, will become 2. And the whole expression is going to be what? 3. Alright, so this becomes the maximum value. Okay. Then let's look at a question on Euclidean. This one is also your trial. The question says, prove given reasons that E1 is equals to 180 minus 2x. This E1 is equals to 180 minus 2x. How are we going to do that? First, we can say that D2 is equals to x. Where is D2? This is D2 is equals to what? X. And the reason is angle opposite equals side. Why? Because this length is equal to that length. So this angle is equal to that angle. That is angle opposite equals side. Then we can continue to say that D1 is also equal to what? X. D1 is also equal to x. What is it? It's tan chord theorem. If you check this, this is a triangle and this is a tangent. So this angle is equal to that angle, which is a tan chord theorem. Then when you continue, C2 is also equal to x. C2 is equal to x. Where is C2? This is C2. C2 is also equal to what? X. Alright. And that is also what? A tan chord theorem. So when we combine them, we can say that E1, this E1 plus D1 plus C2 is going to give us 180. Then remember we found D1 to be X and C2 also to be X. So it means we are going to have E1 plus X, which is going to give us E1 plus 2X. Then if I transpose 2x to this side, I'm going to have 180 minus 2x, which is proved. Okay. Then the next question also says that prove given reason that triangle ECD is similar to triangle CBD. Where is ECD? ECD. We want to prove that this triangle is similar to CBD, this one. So when you are given this question, you try to highlight this side with a different color and highlight this one also, so that it helps you to prove easily. Okay, so the first one, normally when you are proving, you must ensure that this angle, that is E, is equals to C, this C is equals to B, and this D is equals to D. How are you going to do that? You have to determine it from the triangles given, the triangles you are trying to prove that they are similar. So E, from which triangle? From this one, because we want ECD. So here you will say E1. You must make sure that you prove that E1 is equals to what? C. Which C are we talking about? C in this triangle is what? C3. You must prove that E1 is equals to C3. Now if you check this, it's not easy to find out from here this and that. So you move to the next one. Okay, C and B. So which C are we talking about? C on this triangle is C2. Then B on this is what? X. So this one is easy to prove because we prove it above. So you can pick that one and say, okay, C2 is equals to what? B, which is the same as X. And this, if you check this, is what? Tan chord. Then the next one. Remember, we have this outstanding to prove. Alright. So the next one is we are going to prove this D and this D. Which D are we talking about? D on this first triangle is D1. And D on the other one, this triangle is what? D2. So we need to prove that D1 is equals to what? D2. Okay. So here D1 is equal to what? D2. We prove it above that this is equal to that one, which is a tan chord. And we also realize that D2 is also equal to B, angle opposite equals side. Alright, so this one is already proved above. So this angle is equal to that angle because this is a tan chord for this, and this is also equal to that one, which is angle opposite equals side. It was proved above. Let me show you. D1 is equals to X, tan chord. D2 is also equal to X, angle opposite equals side. Okay. Then the last one, which is the angle, the one that we couldn't figure out. So that becomes the third angle of a triangle. If this angle is equals to that one, tan chord, and this one is equals to this one, then this angle would definitely be equal. That's the third side of a triangle, or you can say angles in what? In a triangle. So we have proved that they are similar. Angle, angle, angle. Okay, see you once again. Bye.